All right, page 16, quadratic transformations. So I'm going to go ahead and flip and we'll get it set up. So vertex form of a quadratic is actually, I told y'all last week, it's the easiest form to look at. Because when you look at vertex form, what can you easily see? The vertex. So if we know where that vertex is, the point of the parabola, the turning point, then it should be really easy to find everything else. So when we graph parabolas, we graph them by finding the transformations and then plotting those features from vertex form, okay? So in vertex form, the sign in front of A, what does that tell me? Whether there's a max or min, what did you say, Henry? Good, the direction of opening, very good. So direction of opening, whether it has a max or min, good job, Evan, I liked that too. So based off of your assignment from Friday, what does the A value tell us? What did you say, Keydrian? When the number got bigger, that was out front, what happened to the graph? Not wider, skinnier. So A tells us how skinny or wide it is. What do you guys want to call that? I've had kids call it like width. I've had kids call it thickness. What do we want to call it? They laughed at me last week because I spelled thick with 2 C's, and I was like, yes. What do y'all want to call it? Width, thickness, what? Doesn't matter.
Thickness.
Okay, thickness. You want it with 2 C's, Viti? Probably like, I don't. Oh, she said short. I love it. So if A is bigger, the bigger the number is, the skinnier that parabola gets. If A is smaller, the wider it'll get. So I brought something to show this to y'all. So I'm gonna pause it. If this number out front is bigger than 1, it gets what? What did y'all just say? The bigger the number gets, the skinnier, because it gets taller, right? So if A is bigger than 1, we call that a vertical stretch, because it's going to stretch and get skinnier. I know mine's kind of sloppy. You can make yours neater. So the smaller A gets, what did you guys say happened to the graph? Yeah, it gets wider. And the word I used up here when I was pushing it away, you're pressing it down. So the word we use in math to say that we're making it smaller or pressing it down is compress, okay? So watch. If A is in between 0 and 1, meaning it's what kind of number? Good. If it's a decimal, because anytime you multiply by a decimal or a fraction, it's going to get smaller, right? Okay, good. So if A is in between 0 and 1, we call this a vertical compression. Zoom that in so y'all can see. That's the tricky part that my kids usually mess up on, is the A value. So if it's bigger than 1, it's going to be a stretch. If it's in between 0 and 1, meaning it's a decimal or a fraction, it's going to be pressed down, which means it'll get wider, okay? Any questions on just the front part, the A? This is all what we should have learned in that Canvas click and drag activity. Any questions? Okay? All right, the H value, what did this tell you? Who remembers from Canvas, from the click and drag? Good. What about the X?
The X of the vertex.
The X of the vertex, which means X values go up and down or left and right? Left and right. Very good, y'all. So look, your X value, whatever's inside with X, tells you your horizontal shift. And then horizontal factors go left or right, right? So I'm going to put left and right. Now, what do we have to remember about that horizontal shift? What does the X value always do, Vidi? Oh no, y'all don't remember. It's okay, I'm gonna get corny. Maybe you'll remember it again. Your ex, boyfriend, girlfriend, whoever, they are your ex for a reason because either you did the opposite of what they wanted you to do or they did the opposite of what you wanted them to do. Either way, they are your ex for a reason. Anything inside with X is gonna do the
Opposite.
So if this says -3, which way are we really gonna move it? +3, good. If it says +3, then we're really gonna move left 3. Does that make sense? So I need you guys to remember that your X is always opposite. I would definitely write that down because that is the other place where kids mess up on transformations, between that and the A value. Everything else y'all are usually really good with. All right, last but not least, what about this K back here? Who remembers what that did in Canvas? Good, up and down, which is called what? Not horizontal, but vertical. Very good. So this is your vertical shift. This will tell us how the parabola moves up or down. Now, is that K inside with the X? No, so it's not going to do the opposite. Whatever it says, that's what you do. So if it says +2, you move it up to +2. If it says down 2, you move it down to -2. Do we feel okay with these transformations? This is like the bulk of the notes right here today. So just being able to look at an equation and tell me what has happened to that equation. Everybody's okay? All right, I'm gonna jump into examples then. All are good. My online people, any questions so far? You guys are okay?
I'm good.
Oh, he said he's good. All right. So for each of these, I just want you guys to describe the transformations. And we'll start off pretty easy. So f of x equals x minus 1 squared plus 5. What kind of function is this? Not what form, what kind of function? Yes, it's quadratic because the degree is 2. We remember that from unit 1, right? Okay, good. It's quadratic, which means we should be able to look at this and see where the vertex is. So look at it because it's in vertex form. Where would the vertex point be?
1, 5.
Good, VD. +1, because remember, inside with x is the opposite. +5. So what this means, we're not starting at the origin if it's at 1, 5. How did I move this? Because the word transformation just means move. How did this move?
To the right 1 and up 5.
Up 5. Does that make sense? That's literally all you have to tell me. Right 1, up 5, because the vertex is at 1, 5. It's not at 0, 0 where it's supposed to be. All graphs should start at 0, 0 unless you move them. Transform just means move. So we shifted this right 1, up 5. Is anybody confused on how that's right and not left? Remember, it's going to move the opposite way of what you think it would. I feel like that was pretty easy. Yes, no, kind of. We okay? All right, let's do another one. Example 2. How did this one move? So what's the vertex of this one?
-2, 0.
Yes. Oh, she is on it. I love you, Beatty. She's getting all the extra credit. There's no number out here, which means it's nothing, right? We didn't move it up or down. So the y is still at 0. Inside with the x always does the opposite of what you think. So she said it shifted left 2, -2, 0, right? It says +2. That means we shifted it left. So I'm going to say shifted left 2. Now, what else is different about this one? Good. So it didn't go up or down. So the vertex.
A.
Huh?
Does it have a -a?
Yes. Okay, good. There's a -a. So I'm going to take y'all back to middle school just for a second. Draw y'all a picture. So this is what a parabola normally looks like. That is already crooked. I'm off to a bad spot, but that's okay. Start. I cannot talk today. I stuttered really bad in a meeting this morning and people were laughing at me. I was embarrassed, but it's okay. All right, this is what a parabola normally looks like. So what Jaden just said is the A is negative, which means, Jaden, how's this one gonna open?
Down.
Down. So I want you guys to think back to middle school. What did I do to the blue U to make it look like the purple? What's the word? Huh? I did what to it? Flipped it. That's the middle school word. What is it is a mirror image. What is the high school level math word for flip? They taught y'all slide, flip, and turn, which stood for a slide is a translation. A turn is a rotation. What is a flip called? It is a transformation. It's a specific kind, though. Dang. If only this was a mirror, I'd be able to see my ding, 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 reflection. So if it opens down, what did I do to it? I flipped it. I reflected it. So when you see a negative out front, yes, that means it opens down, but what that means is the transformation, we flipped it. So what Jordan said, we flip it, that's right. I want you to call it a reflection. I don't think you'll ever see it called flipped in high school, okay? So it was reflected. How was it reflected? If it was opening up and then we flipped it down. What are up and down called? Starts with a V. Vertical, reflected vertically, or you can say vertical reflection. Does that make sense? Yeah? Yes? Okay, we're going to do a couple more and then I'm going to go into the graphing part. So example 3. Let's do... I guess I could use numbers other than 2s, 5s, and 1s. I don't know why those are sticking out. So for function number 3, it is a quadratic because the exponent is 2, meaning it's squared. What kind of transformations do y'all see? How did we move it? It's supposed to start at 0, 0. This vertex is not at 0, 0. So how did I move it?
Shift
Move to the right 5.
5.
Right 5,
Up 1.
up 1. Very good, Jaden. Right 5, up 1.
And how you say it?
I don't know. How do you say it? What do we call it if the number out front is bigger than 1? You write it down. Go look.
Vertical stretch.
Vertical stretch by how much, VD?
2.
2.
By
Very good. So, I am gonna roast some of y'all really quick. Everybody that keeps saying it out loud, I know they're gonna be fine on their homework because they're gonna remember participating in class. Some of y'all just staring. That doesn't mean much for me or you. Humans like learn by speaking stuff, explaining stuff, and hearing it. So participate so some of y'all can get some extra credit. Henry, good job. Right 5, up 1, and Jaden and VD. Excellent work. Right 5, up 1, and then VD, you guys said vertical stretch, right?
Mm-hmm.
By a factor of 2. So I'm stretching this 2 units up. Does that make sense? Because there's a 2 out front. Any questions so far? I'm gonna do like one more and then I'm gonna have y'all do one, okay? And then we're gonna move on. So there are 3 questions on your test coming up next week. 3 out of 17 questions where all you gotta do is pick the right transformations. So I'll give you an equation, it's multiple choice, you have to pick the right ones. Or I'll give you the transformations and you have to pick the right equation, okay? All right, I don't hear questions. We're gonna do like 2 more. I'm gonna do this one and then I'm gonna give y'all one to try. All right, y'all can just blurt them out, participate so you get your points. What kind of transformations do we see in this parabola?
Left 4.
Yes. Yep, that's what they said too, BD. Left 4, down 6. What else do y'all see?
Open.
Yeah.
Vertical stretch by a factor of 1/3.
Okay, so be careful. Remember, if it's a fraction, you are right. But remember, if it's a fraction, that means it's getting smaller. So remember, it's like we're pressing it down. Remember me with that resistance band. If you're pressing it, that's a vertical compression. But I do agree it's by a factor of 1/3. So let's write those out. You guys said left 4. And then y'all said down 6. I agree. And then a vertical compression. And I'm okay if y'all abbreviate. And instead of saying by a factor of 1/3, you can just say vertical compressed by 1/3. That's totally fine with me. I'll let my pre-cal kids do that too. So would y'all believe I have to teach this whole lesson again at the beginning of honors pre-cal every year? Because math 2 teachers either don't spend enough time on it or the kids just don't remember. But this is like super important topic. All right, I'm gonna give y'all one to try. So we are all gonna try number 5 right here. And then what's the third one? What does that negative out front do? Good, reflect it vertically. So what I'm hearing everybody say, this is good. You guys said down 2, and I'm gonna write them underneath the one they go with to see if that'll help some of you. Down 2. Then we said this is a vertical stretch by a factor of 7. So I'm just gonna write by 7. I'm okay if you abbreviate. Now, notice we're only looking at the number, not the sign. You can't stretch something negative times. So this is just a vertical stretch by 7. What did we say the negative did again? Reflects it. So the negative makes it a vertical reflection. Do we feel like we could look at an equation and name transformations? That's 3 out of the 17 problems on your test. I mean, if you can get those 3 right, you're sitting right underneath a 20. I expect no lower than a 20 on the next test. That's a joke. Y'all better not get anywhere near 20 or I'm gonna be pissed. I'm looking at you because you always be stressing. I know you won't get by 20. You wouldn't be at school the next day. We'd be like, where's Jordan? Your mama would have gotten you. Are we okay with name and transformations? If you're not, you're gonna struggle on this next part, so I need to know now. Any questions? Is anybody confused by this negative right here?
So you always only look at the number for A?
Yes, very good. So the negative will just mean it's reflected, Beatty. The number tells you if it was stretched or compressed. So notice up here in the notes how I didn't even say anything about a negative. You just look at the number. If the number is bigger than 1, it's a stretch. If the number is a fraction between 0 and 1, it's a compression. The sign out front is what will tell you the direction of the opening.
Okay.
Does that help?
Yeah.
Awesome. So when I teach y'all graphing with transformations, I am going to show you 2 different ways you can use it. And the 2 ways I'm showing you are the 2 ways that will work for Math 3 and Pre-Cal. I don't even know of a third way, if I'm being 100% honest with you. Like, these are the 2 ways that you'll use again, okay? So graphing with transformations, before we talk about graphing with transformations, we need to talk about what a normal parabola looks like before we transform it, which means before we even move it at all. So do you guys know what a normal function is called in math? It's a specific word. You probably haven't learned it yet, to be honest. And that's okay. I don't teach it to y'all because we don't do transformations in Math 1. So the normal function of a parabola, before you start doing anything to it, that is called the parent function. As soon as you move it, what do you think that's called? The child. I'm not even being funny, like it's a legit thing. So the parent function of a parabola is the normal standard parabola we would expect to see on a graph. The child function is what happens to it after we move it or transform it, okay? Is everybody good? Those can also be called pre-image, which means before, and then post-image, which means after you move. All right, so let's talk about our parent function for a quadratic. So the parent function for a quadratic is just y equals x squared. We haven't done any kind of movement to the x, no shifts, no flips, no nothing. No stretches, no compressions. It's just x squared. Is everybody okay with that? Everybody's good? Okay, so first way you can graph quadratics with transformations, let me use a different color for y'all, is by using tables. So this is going to be really good for my people who are not visual. My people who do better with pictures and stuff, you're probably going to like the second way better. People who are better with actual numbers, you'll like the tables better. But I always try to show y'all at least 2 ways and you can pick which works for you. So to graph quadratics using tables, you have to know what the parent table for a quadratic function is. Okay? So when we use tables in math, I'm hoping they taught you this in middle school. What 3 x values did they have y'all use to graph stuff in middle school?
-1, -1.
Yes. Okay, good. Somebody learned it. Hallelujah. So if you learned it, that means some of these other children learned it, maybe. -1, 0, and 1. You should put the -1 first because it's smallest. Then 0, then 1. So the reason they have y'all use these 3 is because the origin, 0, 0, should be in the middle. And then you have a point to the left and a point to the right. And once you have 3 good points, I teach my Math 1 kids, you can go ahead and connect to the graph. So the reason this has the origin, look at your equation up here. If you put 0 in for x, I hope we're all watching because I don't want anybody to be like, I didn't know where those numbers came from because I didn't pull them out my butt. What's 0 squared? 0. So let's fill in the other 2 points. What is -1 if I put it in for x? What is -1 squared? Positive what? 1. There we go. And what happens when you do 1 squared? You get 1. So if you know this table right here, and you are somebody who's better with numbers than pictures, I'm going to show you how to graph using this table. Is everybody good? Okay. The second way we can graph quadratics is just by using our knowledge of the transformations in the graph. So I'm going to call this graph transformations, but I'm going to abbreviate if that's okay with y'all. Haley, that green is hard to see, isn't it? I'm going to have to throw it. I need new markers. We talked about this last week. I'm too cheap to go get some until like most of these die. Connor, you okay? All right. So graph transformations. If we draw a graph, and you guys plot these 3 points right here. So -1, 1, 0, 0, and 1, 1. It should end up looking -1, 1, 0, 0, 1, 1, like this, right? Y'all agree? So the second way, this is your parent graph. So what I'm about to show you the second way when we do an example is how you can just graph it by looking at the equation and the transformations. You do not have to make tables. Some teachers make their kids write tables. I'm going to teach you to look for the transformations. Like if it says x minus 4 squared plus 5, what does the x minus 4 squared mean? It moved where? Huh? Right 4 and then up 5. Why do you need a table for that? Go right 4, up 5, put a point. You get what I'm saying? So some kids can do it without tables. I'm not going to make you show tables. But my people who aren't great with graphs and pictures, you're going to want to do this way. All right? Does everybody agree this is what a normal standard parabola should look like? This equation with this table and this picture. Y'all okay? Okay, so I'm going to just jump into examples because for some of you, this isn't going to make any sense until we actually do it. All right, so let's pick up with example 6. I want you to graph each parabola. And the first one we're going to start with is, I'm just going to start off real basic because I don't want anybody getting freaked out. Y equals x minus 1 squared plus 2. Y'all are doing good. Y'all hang with me. I know this is a lot. Do you guys want me to show you how to graph it using the tables first or graphing it using transformations? Okay, I heard transformations. People at home, is that okay with y'all?
Yeah.
Okay, my in-class people with their heads down and stuff, y'all stay with me. I'm going to keep it 100% real with y'all. If you can learn how to graph it by transformations, it saves you time and it's easier. So I'm going to do transformations first. That sounds like a good idea. So look at this equation. How did we move the parent function? Because it's not just x squared, there's other stuff. So how did we move this graph? What did we do? Where did we move it?
Right. Once,
Yep.
up.
Good, right 1, up 2. So everybody watch, right 1, up 2. So if I go to graph this, you are going to need to draw a graph. This is why I had y'all get graph paper notebooks. I told you we're going to be doing lots of graphing. Look at your parent function up here in green. Where's the vertex supposed to be? 0, 0, but you guys just told me I moved it right 1 up 2. So everybody watch. If I go right 1 up 2, do y'all agree the vertex is at 1, 2? Everybody see what I did? I just moved it right 1 up 2, like y'all said. Now, did I stretch it or compress it or flip it? No. So I want y'all to learn these patterns right here. We always go left 1 and right 1. So I want a point on the left and a point on the right side. And since we didn't stretch it or compress it, how many should it go up? Just 1. So I'm going to go left 1, up 1, and right 1, up 1. And this is what this graph would look like. Put your vertex at 1, 2, because this is vertex form. And then we're going to learn the patterns of this graph up here. You always get a point on the left and the right. And if there's no stretch or compression, it's just going to go up 1. Is everybody okay with that? Can I do one? So does everybody agree? Instead of being at the origin, we're going to move it left 2. That's my vertex right there, because it doesn't go up or down any. There's nothing out here. Connor, if you don't get it, babe, I need you to ask a question. Huh? You're like shaking your head. So left 2. If it's opening down, I want a point on either side, but am I going to go up 1? No, where would you go?
Down.
Down 1. So there's a point there and a point there. That's it. Bada bing, bada boom. I don't think you need tables. Now, does anybody not understand this and want me to draw the tables?
Miss Poole, I got a question.
Okay, what's up, baby? Let me pause so you're not on the recording. What you got? Speak up if you want the tables. I'm about to step it up. Is that okay? All right, here we go. I'll do like 2 more unless y'all need more than that, but I really feel like we'll be okay with just a couple more. Let's do, oh, it'd be nice if I write y equals 1/2 x squared minus 3. What's wrong? Why are you checking your phone? I don't care. I'm gonna tell her not to text you in math class. All right, is everybody good? Y equals 1/2 x squared minus 3. They just want you to graph it. So I'm gonna draw my coordinate plane. How did this equation move? Not right 3. It's not in parentheses with the x.
3.
What 3?
Down 3.
There we go, down 3. See how it says minus 3 on the outside? If I want you to go left or right, it's going to be inside the parentheses with the x. So we're going down 3. Did it go left or right any? Is there anything in parentheses with the x? No, so the x value is still at 0, but we're going to go down 1, 2, 3 and put a point. So there's my vertex at 0, 3. Remember, this is vertex form. Nothing inside with the x, it's understood 0, and then negative 3 on the outside. So now look at your A. It's positive, so this is going to go over and which direction, up or down? Up, and how many units are we going to go up, y'all? 0.5, half a unit. So everybody look, you go 1 to the left and 1 to the right, and I'm just going to go up halfway to the next one, so right here. Did I lose anybody? I went up a half because that A value is positive 1/2. Keedrine, are you even taking your notes? Are you taking your notes? That's not very bright because you got a notebook check coming up. When you connect them, doesn't this parabola look wider? Yes, because the 1/2 out front shrunk it. So it's going to be fatter, wider, okay? Anybody at home want to see tables?
Yeah.
Okay, I can show you tables for this one. So let me draw you some tables. Beatty, can you tell me what my 3 parent points are? What do I put in the table?
-1, 0, and 1.
Okay, what goes on the right side?
1, 0, 1.
There you go. So look, we're not moving the x's any, right?
Yeah.
Okay, we are moving it down 3, but before you can even do down 3, think about PEMDAS. What comes first, multiplication or subtraction?
Multiplication.
So we got to multiply it by 1/2, and then I can subtract 3, and that'll give me my ordered pairs. So watch, this 1/2 is not in parentheses with the x, which means it is with the y. So I'm going to multiply by 1/2 and then subtract 3, and that should tell you what your new ordered pairs are. So my x's aren't going to change, and if you look at this graph, they don't change. It's -1, 0, 1. So y'all watch in case you need to do tables, okay? What is 1 times 1/2? What's 1 times anything? Itself. It's not 1, Lord Jesus. 1 times anything is itself. So 1 times 1/2 is just 1/2. Yes, Chris is like, dang, come on, y'all. What's 1/2 minus 3? -2.5. Chris, good job, babe. -2.5. Same thing here, BD. So watch. What's 0 times 1/2?
0.
What's 0 minus 3?
-3.
Good. What's 1 times 1/2?
1/2.
What's 1/2 minus 3?
-3.5.
-2.5.
2.5.
Yes, we got to work on y'all's mental math. The middle school teachers let y'all use calculators too much. 0.5 minus 3. They got different signs, so you subtract them. 3 minus 1/2 is 2.5, and it should be negative. So these 3 ordered pairs, BD, match what I did right there. Just another way to do it. So if you like the tables, you can do the tables, okay?
Okay, so you would do all that on the y?
Yes, because nothing is in parentheses with the x. If I want you to do stuff to the x, I have to put it in parentheses with the x, because this is where we said our horizontal stuff happens. This is outside, and we said vertical, vertical. This is outside, we said vertical. So all of this, because it's all outside, there's no parentheses and nothing inside with the x, is vertical.
Okay.
All right, I'm gonna give y'all like one more. I'm losing a lot of my in-person people, and they're disappointing me today. I got some mamas to call this afternoon. Let's do, I'm gonna give y'all this one a try. So I am gonna pause the recording after I write it, and you guys are gonna try this one. All right, so you guys try this one. You can either do transformations or tables. I can show you both if you want them, and then I'm gonna turn y'all loose. I'm gonna take that as a yes. Nobody objected. All right, in-class people that did not use tables, because I don't think most of you are. I think I got a few, which is good. Where is the vertex of this parabola? -1, 2, because we moved it left 1, up 2, right? Okay, so if I go left 1, up 2, do y'all agree this is my vertex? Okay, so what did y'all look at next to graph it? Oh, good. Okay, I heard the sign, I heard the A, I heard it's negative. Perfect. If it's negative, which way is it opening?
Down.
So which means when we go over 1 both ways, we're going to go down. Now, how many are we going to go down? What's the A value? So did you guys go down 2 on either side of that middle point?
Yes.
Look at y'all. That's it. That's as hard as it can get. Now, I'm going to keep it real with you. I gave you a couple challenge problems on the homework where instead of me giving you the equation, what do you think I gave you? the graph, and I asked you to write the equation. So let's see if we could work backwards. If you look at this graph, could you guys find the vertex? Then could y'all figure out how many it went up or down? Yeah, and if it goes down, you know it just has to be negative, right? Do we have any questions on transformations before we go work on our homework?